This is video 8 for chapter 11 of Levin's book, Statistics for Managers. At the end of the previous video, we just examined all the formulas and ingredients that went into the two-way analysis of variance. One of them was the n prime value, which was the value, the number of replicates in each cell, as they put it. And we're going to look at what they call cell in a minute. Let's just follow the text and then look at the new values. To examine the two-way ANOVA, return to the using statistics scenario on page 422. That's the very first page in the chapter. As production manager at Perfect Parachutes, you have decided not only to evaluate the different suppliers, which we did in the first part. That was completely randomized design. That's with one factor. One factor had 4 levels. That's how it was randomized. They were not tied to anything. That was one-way ANOVA. So not only evaluate different suppliers, but also determine whether parachutes woven on the Jetta looms are as strong as those woven on the Turk looms. And as usual, they don't tell you in a clear language that we are going to look at the same experiment, which was now performed clearly on 2 different looms. In the previous section, we pretended the looms were the same. We did not differentiate between the looms, or maybe all 20 parachutes in the previous part of the chapter were made on one loom, on the same loom. In addition, you need to determine whether any differences, that's another keyword, whether any differences among the 4 suppliers in the strength of the parachutes are dependent on the type of loom being used. Thus, you have decided to perform an experiment in which 5 different parachutes from each supplier, pay attention to this, 5 different parachutes from each supplier are manufactured on each of the 2 different looms. We have 4 suppliers. We have 5 parachutes. That was the first part. We had 20 values. Since 4 suppliers provided fibers for 5 parachutes from each supplier, we had 20 parachutes. Now we're doing the same on 2 looms. Therefore, the count is 40. 5 different parachutes from each supplier are manufactured on each of the 2 different looms. The results are given in table 11.7 and stored in parachute 2. Okay. These are the data that we're going to use. We have 2 factors here. This is the factor we're looking at right now, which we did not use in the previous section. This is factor A. The type of loom, the Jetta brand and the Turk brand. That's one factor. And the supplier is the factor with which we're already familiar. Now the key here is to understand the terminology. This is the cell. This is what is called a cell. It's not really separated from other cells like these cells in Excel, but the terminology that is used for two-way ANOVA includes the term cell, and that's what it means right here. In our case, we have 5 parachutes made on this loom, on the Jetta brand, from the fibers supplied by supplier 1. 1, 2, 3, 4, 5. Same fibers also went into the production on the Turk loom, another 5 values for tensile strength. So these are the values of tensile strength. They are the result of the destructive testing on each of the 40 parachutes. But they were grouped before testing. They were grouped by the manufacturing protocol. It included this set of parachutes, this set of parachutes. All 8 sets were designed to provide the data, which are grouped like this. Going back to the text. On this page, they present us immediately with a two-way ANOVA, which we're going to reproduce right now. And this shows the summary table, the ANOVA summary table, which is different from one-way ANOVA summary table. This is the two-way ANOVA summary table. This is two-factor with replication. This is what we're going to pick from the menu in the data analysis toolpath. Let's do that. These are the data. I colored them a little bit so they have a clearer view of what we're doing. Crop from here. Okay. We're going to choose two-way ANOVA with replication because the tests were replicated. Several levels of this factor, the factor supplier, exist. And these levels correspond to this one level of another factor, the second factor. Had this only been one meaning here for the brand factor, this would be two-way ANOVA without replication. It's still two-way because we would have had the brand factor and the supplier factor. However, the testing would not be replicated. We would only have one result for the supplier factor, for example. So we're going to choose, I'm going to go to data, data analysis, not here, no. I'm going to go to data, data analysis, two-factor with replication. I'm going to say OK. Now, we're going to select the entire data set. And here's something to pay attention to. They are asking us for rows per sample. It's here where we need to enter the number of replications. 1, 2, 3, 4, 5. That's exactly where it goes. And it also tells Excel that the next 5 values belong to the next level of the brand factor. So it knows to stop here for the Jetta brand and start here for the chart brand. And they're labeled appropriately. The significance level is the same, 5%, and we're going to select the output range. This is good, clearly visible. Very good. So let's run the analysis. Here we go. And we're going to compare it to what we have in the book. P-value, first of all, is 0.37. Which tells us not to reject the null hypothesis here. Okay. The correct 0.37. See that. .37, that's correct. Critical value for F is 4.14, and everything else is the same. So we have reproduced this test. In figure 11.10, which is this one, right? The summary tables provide the sample size, sum, mean, and variance for each combination of supplier and loom. That's what we've got here. We have combinations of supplier and loom. This is combination number 1 right here. This is the other one. Let's put some color here. A little bit. Is Jetta. Okay, Jetta was pink. Let's make Jetta pink. Okay. We have a total. Okay, these are the combinations. Sample size, sum, mean, and variance. Sample size, sum, mean, and variance. Sample size, sum, mean, which is average, and variance, right here. Sample size, sum, mean, and variance. And we can certainly see our suppliers listed here as well. Let's use the same colors. Oh, we don't get to have this one. Turk. Let's help with it a little bit. Make our life easier. Copy it and dump it over here and make it blue. Now it's easier to read a little bit. Okay. The total columns in the first two tables provide these statistics for each loom, and the third table, this one right here, the third table provides them for each supplier. You can see that from the counts here. Obviously, we have 10 parachutes from each supplier because if you remember in the beginning of this test, we reminded ourselves that we are dealing with 40 parachutes. It's right here. Okay, let's pretty this one up a little bit. Make sure we're looking at the same everything. Okay. In addition, in the ANOVA table, degrees of freedom represents degrees of freedom. Sum of squares refers to sum of squares. Mean squares stands for mean squares, and F is the F statistic, computed test statistic. Let's see what they have here. Okay. Table E.5, that's on the back of the book, does not provide the upper tail critical values from the F distribution with 32 degrees of freedom in the denominator, which is right here. Table E.5 gives critical values either for F distributions with 30 degrees of freedom in the denominator or for F distributions with 40 degrees of freedom in the denominator. When the desired degrees of freedom are not provided in the table, you can round to the closest value that is given or use the p-value approach. They're giving you this description of your future problem when you start looking at the problems at the end of the chapter. And I'm saying that because as far as Excel is concerned, and that's what we have just reproduced, they have all the values they need. They are telling you that you cannot find, for example, this in what the book has provided exactly, but that's okay. In the previous video, we have seen that all these tables are available on the internet. To interpret the results, you start by testing whether there is an interaction effect between factor A, that's loom, and factor B, the supplier. If the interaction effect, in other words, we remember what interaction effect means. Do these values depend on these values? Or do these values depend on these values? If the answer is yes, if they do depend, then there is an interaction. If they don't depend on each other, there is no interaction. If the interaction effect is significant, that means we're sure it's not due to chance. We're sure to a certain degree expressed in percentage points. that it's not due to chance. If the interaction effect is significant, further analysis will refer only to this interaction. In other words, we'll be looking at interaction only. If the interaction effect is not significant, you will focus on the main effects. An important thing to remember. That's A and B. Main effects. That means the separate factors, main effects. A is a main effect. B is a main effect. So we'll be looking at those only. Main effects are separately acting factors. You can focus on the main effects, potential differences in looms, factor A, and potential differences in suppliers, factor B. Using the 5% level of significance to determine whether there is evidence of an interaction effect, you reject the null hypothesis of no interaction between loom and supplier, and if the computed F value is greater than 2.92. The approximate upper tail critical value from the F distribution, that's the critical value, with 3 and 32 degrees of freedom. Because F of 0.0111 is less than the critical value, 2.92, or the p-value is close to 1, it's 0.99, which is greater than 5%, you do not reject HO. Did they clearly state the HO, the null? No, they did not clearly state the null. In this chapter, they did not. This is the null hypothesis. No interaction. The null states there is no interaction. I think they stated this clearly a little earlier. Null hypothesis of no interaction. Let's say this and go back a little bit to page 18. Maybe 17. This is the null. They did state it clearly. Okay. Of no difference due to factor A, 3 distinct tests to perform. There is no difference due to factor A. There's the alternative. There is no difference in means due to factor A. Another test, test number 2, no difference due to factor B. The means are the same. Okay. And here's interaction. To test the null hypothesis of no interaction of factors A and B. Okay. The interaction of A and B is equal to 0. So, when we're testing means, in a two-way analysis of variance, we're testing the null for interaction effects. We're testing this third test. The interaction of A and B is equal to 0. And if the p-value exceeds 5%, and in our case it's far greater than 5%, it does not fall into the rejection region. That means we fail to reject. We do not reject the null hypothesis here. Okay, using 5% level of significance to determine whether there is evidence of an interaction effect, you reject the null hypothesis of no interaction between loom and supplier if the computed F value is greater than 2.92. Where is 2.92? Here. This is the critical value and the computed value. That's what we're looking at. Let's make critical red. Because F of 0.011, somewhere over here, is much less than the critical value, right over here. We are staying away from the region of rejection, which is this. The p-value of 0.9984, do we have it? Right here, 0.9984. Let's do this. This is annoying. Okay. Too many cells. Okay, 2 decimals after the decimal point. Okay, let's make it look good. Okay. Because the computed value is far less than the critical value, and the p-value, oh, this is not what we wanted here. Okay. The p-value is 998 right here. We got it. We do not reject the null, and the null stated that there is no interaction. You conclude that there is insufficient evidence of an interaction effect between loom and supplier. Okay. You can now focus on the main effects. Let's focus on the main effects. That's the 2 factors we have. Using the 5% level of significance and testing for a difference between the 2 looms, factor A, you reject the null hypothesis if the calculated F value is greater than 4.17. The approximate upper tail critical value from the F distribution with 1 and 32 degrees of freedom. Okay, if you remember, we had 2 separate null hypotheses for main effects. Although they were separate, they sounded practically the same. Null hypotheses for main effects deal with the mean values of tensile stress, and that's the test results. So for factor A, the null was mu1 equals mu2 equals mu4. That's the mean tensile stress due to factor A, and factor A is the brand. Okay, because f, that's the computed value, is less than the critical value, 4.17, you do not reject the null. Let's find it over here. We have 4.15, not 17. And the computed value of 0.81. Well, clearly this is less than this. This is staying very far away from this rejection region. This is the rejection region. Why is this 4.17? Let's look at it really quickly. Well, we know why, because it's a typo. That's the typo, so don't be concerned with that. How the heck it got into this? Maybe they calculated this by hand without looking at the two-way ANOVA summary tables. Okay, but by looking at p-value alone, we can see how far into this non-rejection region, non-rejection right here, it gets compared to 5%, which is right here. So we fail to reject the null. So there is insufficient evidence of a difference between the looms in terms of the mean tensile strengths of the parachutes manufactured. At this point, we're done looking at factor A. And it was right here. This was factor A over here. Let's give it some color. Give something like that. There you go. We're done with this. We're done with interaction. We had to look at interaction first because if this were significant, if this were less than 5%, then we wouldn't even look at these. We had to concentrate, we would have concentrated on the interaction. But this was not significant, so we're looking at main effects. Well, here we go. We looked at the brand effect. Two different looms seem to be operating not much differently. Nothing depends on them. As far as measuring the mean tensile strength, none of those values depended on the type of the loom. And we're looking briefly, let's just glance at the columns, which were the suppliers. These are the columns. Okay. And this difference is significant because p-value falls into the rejection region. So we reject the null hypothesis of equality of means for factor B. Using the 5% level of significance and testing for a difference among the suppliers, that's factor B, you reject the null hypothesis of no difference if the calculated F value exceeds 2.92. Well, we only have 2.90 here. There are some small discrepancies between the calculated Excel calculated two-way ANOVA summary tables and what they calculated by hand. Okay. If the calculated F value exceeds 2.92, the approximate upper tail critical value right here, critical value, from the F distribution with 3 degrees of freedom, this comma is unnecessary here, not a typo, with 3 degrees of freedom, that's 4 minus 1 obviously, in the numerator, and 32 degrees of freedom, 40 minus 8, in the denominator. See figure 11.11. It's on the previous page. Because F the calculated value is 5.19, practically 5.2, is greater than 2.92, or the p-value is 0.0049, something like this, reject the null. So we can see now that we reject the hypothesis of equality of means due to factor B, due to differences in supply errors. So there's something there. There's a difference. Some suppliers are different from other suppliers. You conclude that there is evidence of a difference among the suppliers in terms of the mean tensile strength of the parachutes. Interpreting interaction effects. You can get a better understanding of the interpretation of the interaction by plotting the cell means. Keyword, cell means. Cell means. That is the means of all possible factor level combinations as shown in figure 11.13 right here. I highlighted these two words because we calculated the cell means in one-way ANOVA when we had 20 parachutes. In two-way ANOVA, in this chapter, we have 40 parachutes. So we cannot use the means we calculated in the one-way ANOVA. We have to recalculate the means. And their explanation doesn't make it much clearer. That is the means of all possible factor level combinations. It's just the means for all levels of each supplier. We had 5 levels for each supplier in one-way ANOVA. All possible factor levels, this possible should go away. For all factor level, all possible factor level combinations should go away. This is misleading. Just for all levels, for all factor levels, as shown in figure 11.3. Okay, figure 11.10 on page 442 provides the cell means for the loom supplier combination. From the plot of the mean tensile strength for each combination of loom and supplier, observe that the two lines representing the two looms, here's one line, here is the other line. Two lines representing the two looms are roughly parallel. They are pretty much parallel. This indicates that the difference between the mean tensile strength of the two looms is virtually the same for the 4 suppliers. In other words, they do not intersect anywhere. In other words, there is no interaction between these two factors, as was clearly substantiated from the F test. Okay. We're going to reproduce that graph in a second. What is the interpretation if there is an interaction? If there is an interaction. In such a situation, some levels of factor A would respond better with certain levels of factor B. For example, with respect to tensile strength, suppose that some suppliers were better for the jet loom and other suppliers were better for the circle loom. That makes perfect sense, actually. That happens. If this were true, the lines in figure 11.3 we just looked at, those parallel lines, would not be nearly as parallel as and the interaction effect might be statistically significant. In such a situation, the difference between the looms is no longer the same for all suppliers. Such an outcome would also complicate the interpretation of the main effects. They're hard to interpret when they depend on each other like that, because differences in one factor, the loom, are not consistent across the other factor, the supplier. Then I'm going to show us another example which does not involve the parachutes and the looms. Okay, they promised us the values for the means, but we'll just calculate them. Okay. We'll just calculate them. Let's do this. We're gonna move the ANOVA to the side a little bit. Okay. Now, what we're going to do is separate them and calculate the mean. So this is Jetta. Okay, we got our means for the Jetta brand. We'll do the same for the Turk. Okay. Now these two guys are what we need. Okay. From here, we'll just grab the two line. This is a typical line type graph. And Excel picks it up immediately. So we're pretty close to what we have seen in the text. The lines are nearly parallel. Very, very close to absolute parallel. Let's format this a little bit. Marker to solid. They had something like squares there. Yeah, they had the squares. Built-in square. Yeah, something like that. And these were circles. Make it a little bit larger in size. And the greater strength was shown slightly greater was on the Turk. And this was Jetta. Okay. Let's go back and see. This was made in Excel 2003. So well, strangely, we have squares on the top curve, but they're placed on the bottom. And the circles in the bottom, oh, those were, I don't know, let's pretend they're circles. Yeah, these are circles. Anyway, we did a better job here, actually. Did we? No, we didn't. Okay, now we're completely in agreement with them. Okay, that's how Excel works. Okay. Next, we're going to have to reproduce the other example that they have. Something having to do with ACT scores. And after that, we'll conclude with the Tukey-Kramer, with the Tukey procedure, Tukey multiple comparisons procedure. Oh, it is Tukey-Kramer. For one factor. We will redo pretty much what we did in section 1, but this is all simplified, obviously. This time we'll be dealing with 40 values of tensile strength. So this Tukey-Kramer analysis will not be in principle, in its essence, any different from what we did in section 1. They just made it simple. They simplified it. So, okay, let's stop here.